Okay, well, welcome to our webinar here on electrical engineering at UBC. My name's Thomas Johnson, and I'm the program chair for the electrical and computer engineering program in the School of Engineering at the Kelowna campus of UBC. And my colleagues with me today, Sudeep, you want to introduce yourself?
Yeah, so my name is Sudeep Shekhar, and I'm a professor in electrical and computer engineering at UBC Vancouver.
Thanks, Sudeep. So we want to share a few slides with you, and then we're going to open it up to questions and answer. So to begin with, motivating the field of electrical engineering, we've got a slide here that we're going to just review some of the top technology inventions in the 20th century. And I think that is an interesting thing to reflect on. It does highlight just how many of these inventions relate to electrical engineering. So if we go way back, there's a picture of a radio. Perhaps some of you may not have ever even seen something like this. You'd have to go to the museum to see that maybe. Radio, aircraft, early aircraft, televisions. That's a nice looking antique. Antibiotics, radar, nuclear fusion. Then we come into artificial intelligence, and quite surprisingly, this was some of the earliest work on this does even go back to the 50s, 40s and 50s. And of course, it's a very big area these days. Chips, integrated circuit. You're sort of now looking around the late 1950s, early 1960s. We have space exploration and rockets, lasers and optics. Then we got the advent of the personal computer. And then we have the internet. And of course, getting right up to our modern day smartphones and the really the mobile devices that we almost all have. And if you look at these different inventions, the boxes that are highlighted here on the screen, all of these have some relationship to electrical engineering, and the people who discovered these have all contributed significantly to the development of electrical engineering technology. So it really is very broad and has been instrumental in creating a lot of innovative technology. More recently, here's another news clip that Sudeep found that related to the GDP of the United States. And what's very interesting here is without data centers, the GDP growth of the United States would be at 0.1% for the first half of 2025. So the converse of that is that the GDP of the United States is heavily dependent on the build out of data centers, and the data centers, AI, and a lot of the technology associated with that has really significantly contributed to the development of the economy. And so a lot of this is resting on electrical engineering training. So at UBC, we have two campuses. And here is just a map of showing, this is BC. So over here is Vancouver, and this is the Point Grey campus. That's where Sudeep is located. It's a larger campus right at the end of it borders on the water, and that's the if you zoomed in, this would be the electrical and computer engineering building in Vancouver. And over here, about 400 kilometers away in the interior of BC, is where Kelowna is, and that's where I'm located. And we have a second campus out there, and it is neighboring on some very nice lakes. And in both places, I think one of the very attractive places or things about UBC is at both of our campuses, the environment is very nice, and it's a very welcoming and great place to study. So what is electrical engineering? It's a very broad field. There are many different areas that you can specialize in, and we just got a few listed here. These are in alphabetical order, but starting at the top, communication systems and computer networks. And that can include other aspects like cybersecurity and cryptocurrencies, learning algorithms, blockchain. Controls another big area. It's been a very classical area within electrical engineering, and it does link up with some aspects of mechanical engineering, and this would be sort of where you would see things like automation and control of machines and robotics and autonomous vehicles. We have electronics and microelectronics. It's a huge area, and everything from power electronic type circuits to digital circuits, analog circuits, circuits for biomedical applications. This is all your chips and printed circuit boards. Another area in electrical engineering is photonics, your optical communications, as well as very high frequencies. The terahertz is another area of very high frequency work. This is used for communication applications, sensing applications. Power systems and energy transition, probably a very classical area. Certainly if you go back decades in electrical engineering, this would be probably one of the major focus areas for electrical engineering. It is still an extremely important part of electrical engineering and relating to generation, transmission, and distribution of electrical power. And of course, we see a lot of new work in terms of renewable energy and energy storage. These are all very important aspects of the generation of power. And another area within electrical engineering is focusing on signal processing and data analysis. This is usually implemented in software, but it could also be implemented by specialized hardware. And that's getting information and processing signals that we might get from sensors or electronic systems. If you enroll in electrical engineering, there's a really wide range of courses that you would take in your early years of the program. You build up fundamental knowledge, maybe in things like circuits and mathematics and electromagnetics and digital circuits. And then as you progress to your more senior levels of study, you can specialize in different areas, maybe in microelectronics or communications, analog RF circuit design, antennas, and various other areas, power systems. Also within our programs, we've got specializations in biomedical and mechatronics. You can choose to select a set of electives that focus on these areas. When our students graduate, there are many, many types of jobs that they could find employment in. Here's a page with just some possibilities. We've got embedded systems, hardware, software design, power systems, renewable energy, computer-aided design, tools engineers. Almost all of our design work in electrical engineering will use some kind of software tools. Radio frequency engineers, photonics is a growing area, digital signal processing, safety and test and verification. In many of our complex systems, actually the verification and test of systems is a really, really significant and important part of the design process. digital, mixed signal, analog RF, integrated circuit designers, and field programmable gate arrays. These are reconfigurable digital hardware platforms. Those are all examples of jobs that can branch out of electrical engineering. Our graduates go to lots of different companies. On this page, it's just listed. So these are some companies that are more around the Kelowna area. And then on the next page, this is what you might find in the Lower Mainland. These are a lot of big companies located there. And of course, our alumni go not just to the Vancouver and Kelowna areas, they go across the country and internationally. So many, many opportunities. In terms of, what do I think is the most exciting about electrical engineering? And I mean, these are actually sort of personal takes on electrical engineering. I think one area that I find very interesting is the fusing of hardware and software and bringing these systems together. It's almost every hardware system now has some aspect of software, and that whole junction and integrating these two things together is really an interesting area. Another thing is in electrical engineering, our systems are very complex. So, at the bottom here, I've got some points that just the complexity of the systems. How do you design them? How do you verify them? How do you make sure that they're reliable? Really, really interesting aspects of electrical engineering. And so there's many, many different pathways out of electrical engineering. What's a challenging course concept, and what's its applicability to the real world? Well, something I've found in teaching and working with a lot of undergraduate students at UBC, we have a series of courses in the area we call electromagnetics. This is basically where you're talking about electric fields and magnetic fields. These kind of fields, it's like gravity. You can't see it, but they're really fundamental to understanding things like wireless communications or optics. And in terms of quantum computing, this is a very physics-based area that also uses a lot of electromagnetic concepts. So it has in the beginning, there's a lot of mathematical tools that we use to describe these fields, and then we've got a lot of software to help visualize and bring visualization and design aids to this. But I think I would say a lot of students do find this to be a challenging area, but it's extremely important. And in terms of some, very cool and innovative or life-changing research projects, UBC is a research-intensive university. Many of the professors that you'd be having classes with have their research programs. That brings a lot of really current knowledge and application to your classes, and also good opportunities to talk to the professors, and many of them have opportunities for collaborative work. Maybe students can join some of their research activities as an undergrad research assistant, and this is a great opportunity for undergraduate students. And so here are just a bunch of different areas that many of our professors work in. And with that, that's everything. I will stop there, and we're now open for questions and answers.
All right. So if on Zoom, you would see, at least on mine, there is a button called More with 3 dots. And if you click there, there is Q&A option, or you may see it even as a separate panel. So go to the Q&A and you can type in your questions there. All right, we have our first question. which is what high school average do you recommend in grade 11th and 12th?
So, yeah, I don't know if I give really hard numbers. Related to the admission process, at least in the School of Engineering on the Okanagan campus, we have what are called bands, different banded layers, and really does depend on the applicant pools. But I would say that I think last year we're seeing students in the maybe 85% and above type of range that are coming into engineering. I don't know, Sudeep, what it would be for your programs. Do you have any numbers there in terms of admission?
I don't. I think it's upper 80s. I
Mm-hmm.
don't have the precise number.
And there is a competitive entry process there, so it does tend to be a lot about relative to the group of applicants. So that's why it does vary a bit year to year. But I think if you're in that range, I would think that there's good opportunities for admission.
Maybe in the meantime, Thomas, I'll ask you a question. So, what is the difference between electrical engineering and computer engineering? Sounds like computer engineering is about building computers, and electrical engineering also is about building computers, or is there a distinction?
Well, I think the way I describe it, to me, this is sort of the spectrum of electrical engineering, and I think electrical engineering, the programs that we're talking about here tonight, right? It is very broad, and you could go into power, you could have circuit design, we got photonics. It keeps many options open. But if you have a more focused interest on the computing side, as well as maybe some interest on the software side. Computer engineering is at the convergence of software and hardware. And at the Okanagan campus, the computer engineering program actually is built on top of electrical engineering courses and some computer science courses and computer engineering courses as the bridge between these two things. So I would say it's there with a little bit more focus on that blending that software and hardware side of things, and but still really at this interface between the two of them. So it's a spectrum, and that's how I'd really describe it.
Yeah, another question is just describing the program, right? So the admission is uh, common, right? And the departments are chosen at the end of the first year, right? In both the campuses, is that right?
Yes, that's right. Yeah, so you come in, and because often students, well, first of all, there's many fundamental things that we need to establish. I think the math and the there's basic courses in like electricity and magnetism, and these foundational things that are good for many of the different engineering disciplines. It includes some things like statics and dynamics, some of the mechanical things too.
Okay, there's another question on the Q&A panel. What are some electives for the electrical engineering program?
So I think to answer that, I'd just go back to the slide that really talked about electrical engineering. Like, what is electrical engineering? I'm going to say this slide, you're looking at the kind of range of electives that we offer. We have electives in all of these areas. And so communications, control, electronics, microelectronics, integrated circuit design, photonics, power systems, signal processing, machine learning. Those are all examples of electives that you can take in your fourth year.
And again, I would ask a follow-up question. Are some of these electives packaged as a certificate or an option or some, are they free to take any electives?
So you're free to take any electives, providing you meet the prerequisites. So often they do require some prerequisites, mostly maybe at the third year level of electrical engineering, and then you can take any of the design electives. If you are doing a specialization like biomedical or mechatronics, these would have a set of a course basket a bit more constrained, that you would need to take the electives out of this pool to get that concentration or that option. So for those special cases, it would be more constrained.
All right, we have time for maybe one or two more questions. So if you have any last question, please type it in the Q&A panel. Okay, there's one. Are co-ops a requirement? And if so, what are some co-op examples provided in electrical engineering? How long should each co-op be?
So co-op is not a requirement. It is an option. So you can enroll in co-op. I would say when I was an undergrad student, I took co-op. It was amazing. It added a lot to the undergrad student experience. And I hear the same thing from students, all the students I know of that take co-op. It's a huge asset. It gives you experience. It helps you identify maybe areas you want to focus in on. How long are those co-ops? They can vary. They can be anything from a 4-month co-op to 8 months, up to 16. I've heard as far as even like 16 months. One thing that I think we're seeing amongst some employers, co-op employers, is that they do like the longer blocks, because when you come in, those first few months, you might be training and getting familiar with the processes or tools. And then after that, you can really start maybe contributing and being more involved in a project. And actually, that's even better experience. So I'm noticing students that might have co-ops up to 16 months. What are the kind of companies? Basically, many of these companies that we had listed on these pages are examples. A lot of them will take co-op students. And I've even talked to some employers that they look for that co-op even in their hiring. It's kind of a screening type of thing, because it just helps them, differentiate, between the different students. So it's, I would really argue it's a highly beneficial thing to consider.
Okay, so I think, let's see. I don't see any more questions, and it's also time. So thank you for coming to this session. And yeah, I think we'll wrap up the session now. Thomas, we can end this session.
All right. Thank you. And bye for now.